one has that much of time that if you, in order to read the 10 files, we need to wait for 100 minutes. So everybody in this world needs instant output. So by default, Java is a single threaded process. So in multitasking and simultaneous things are very important for us. Another example, let's say if a builder wants to build a building, if that person is alone, try to build a building, that might take years and years. But that's why a builder has to hire lots of people in order to complete their task quickly. So Java is also giving you the facility that rather than working with only one single thread, that's a main thread, by default your program is running in a single thread model. You can create more than one thread according to your requirement, and then you can increase your throughput. Throughput means like time saving. So there are another important part is, let's say, process and thread. So if you see in your computer, if you go to task manager, so there are processes. Okay, so this Eclipse, then Chrome. So there are so many processes are running. So processes are different than thread. So process is heavyweight. Okay, so if you want to switch from one process to another process, let's say Google Chrome. So in Chrome we have multiple tabs are open. So if you are switching from one tab to another tab, that is part of one process. The process is Chrome. So process are high level, okay, and then a heavyweight, but threads are sub part of the process, and they are sharing the same memory space. But one Eclipse or process is with another process, with respect to other process, they are not sharing the same memory space. Okay, so that's one example of the process. So there are two ways you can achieve multitasking. So if you remember, like say earlier days, we have single core processor, then dual core processor, then quad core, then octa core, right? So those different processors are helping us to increase our simultaneous working capability, and that's why we have these faster machines nowadays. But we are not focusing on multitasking with process-based multitasking, but we are focusing on thread-based multitasking. So here they have given whatever I was discussing so far, like process-based multitasking. Each process has address in memory. In other words, allocate the separate memory. Yeah, process is heavyweight. Cost of communication between the process is high. Switching from one process to another process requires some time. And thread-based multitasking is threads share the same address space. Thread is lightweight, and cost of communication with thread is low. It's the same thing what we discussed so far. And there are multiple processes are running in your application, your program, ultimately your machine. Then they have multiple threads inside in order to give you the faster output. And there is a class called thread in Java. So for now, you don't need to worry about all this method, but by end of the thread session, you will come across all these methods for sure. Okay, so no need to worry with the example. So no need to spend time here. Just read it. Okay, and we're going to put public. Okay, so and I'm just going to create one class. Okay, simply first of all, we are going to run. So we'll prove all this point like we are getting the simultaneous output. Okay, so first of all, let's run this simple code. So you can see like current thread name. So by default, Java is running in a single thread model, and that thread name is main. And this is how we can prove that this main method, inside that we are adding thread.current thread.get name, that is printing the name main. That means your current thread, your current program is running in single thread model. That thread name is main. Now, according to the inheritance strategy, you can say my thread is a thread. Toyota is a car. Same thing, my thread is a thread because my thread is extending the thread class. So now let's create an object of my thread. Okay, and then okay, so we are calling the start method. The start method is not defined by you or in this class. Start method is coming from the parent class, which is the thread class. So acquiring a thread from the it's not like immediate kind of we can write a code. That's something which is to deal with the operating system. So that is written in the start method. And the start method, once it is acquired, it will basically call your run method from the new thread. So now if you see here, if you call this, it is thread 0. Likewise, let's say if I want to create another thread, you can create as many thread you want. Okay, so thread 0, thread 1. So basically this is printing in the run method. Okay, so this is coming from here. So this is a proof that this is printing, creating a thread and starting your thread. Now, how can we prove that these threads are running parallel? Okay, so now let me just do a couple more thing here, and then we can prove that all threads are running in parallel. So I'm just creating one variable, or maybe let's do one thing. Okay, that's fine. Let's put the constructor. Okay, now let's see what happened here. Okay, let me just do one thing. Okay, now you can see like all the threads, thread 0, thread 1, okay, and main, all are working at the same time. Main is also running here. Okay, so from while you're running the main, you started 2 thread. Okay, so 3 threads are running at the same time. That's the proof. That's what we need to prove, that multitasking. How can you make sure that it is multitasking? Right, so this is the proof that all 3 threads are working at the same time. So if you give the task, okay, insert this number, you pass, okay, which file you want to read. Here you pass another file. Okay, likewise, you can create many thread and then you pass, let's say 10 files you want to read. Then all 10 threads might read different files for you at the same time. Okay, so this is the advantage here. Now, as he has also mentioned that we can create a thread with interface also. So now let me just create a same example. Instead of my thread, you can do my runnable. Okay, so let me just open my runnable. Now I'm going to change from extend to implement runnable. Okay, so everything is even same, no change at all.
Can you repeat the first method? Like
Which one?
the first one again, like just quickly.
I'll come back. No worries. Let me finish runnable, then I will come back again there. Okay, because this is the same thing we are doing. Okay, so now let me just go here. So what we are doing here, we are just getting a thread here in first method, and then we are calling the start method. That's it, and it is calling your run method in a different thread. Now in the second way, right? Your class is not thread. Okay, now you are implementing runnable. That means it is not a thread. Your mind runnable is runnable. It's not thread. So that means you are not creating a thread. So in order to create a thread, okay, so there are one extra step we have to take. So didn't you create a thread by yourself?
Sorry?
I'm asking Parth, did you create a
Yeah,
thread?
I did. I did like almost similar program like Beetle.
Okay. So if you create a my runnable, okay, here, so in a new my runnable, then because now this is not let's say if you pass 5001, but like this is not a thread. So in order to start the thread, you have to create a thread. So I'm going to create, let's say T1 is equal to new thread, and then you pass runnable as an argument. Okay, so let me just, instead of bigger name, let me just put R1. Okay, and same way I can do R2, T2, and then here R2, and let me just 10,001 here. Okay, I'm just going to, okay, let me do one thing here. Let me just put one more zero. Okay, so
R2 in runnable 2. R2.
oh yeah. Okay, now let's see here what happened. Oh yeah, we have not started yet. Okay, so let me just start it. T1 dot start and T2 dot start. Let me start all together. Okay, now I will see like all thread. Okay, 0, 1, 2, 3. How many threads? All the threads are running and giving me the output. Right. So now you can see here in this code that while you are creating using runnable, you have to create a thread and give that runnable. That where is your run method? Using which object your Java will call your run method. So where is your run method exist? So you have to give runnable object, because this is not thread. Thread you can start by calling only start method. There is only one way. There is no different way. Either you implement the runnable or extend the thread. Ultimately, you have to call the start method. Then without that, it will not start. Okay. So now, in first case, what happened? Your class itself is a thread. That's why Java knows that, okay, I need to call run method from the same class. But here, your class is not thread. So that's why you have to pass this object where exactly Java needs to call your run method. Okay, so which one is better? Let's say we have two ways now to create a thread. So which one is better? So here in this our class, I can call the run method directly. There is no issue. Okay, so let's say I can, instead of calling the start method here. Okay, so instead of calling a start method, okay, everywhere let me just do run. Okay, I just stop all the start method and I directly call run method. Okay, that's fine. See, first, whatever the thread has started first, Okay, here. Okay, which one is the run method here? First time I call here. So this is my thread. Okay, so my thread starting with 5,000. So until unless this does not complete, it will not go further. So it's a sequential, simple program.
Okay.
It's not starting a new thread. You can call the run method. There is nothing wrong because it's instance method. But you're not starting a new thread. You see, the thread name is main only. Directly you're calling the run method, right? That means you are calling from the run method. You're not creating a new thread. Okay, so this is important topic. So let me just quickly cover all the small topics. Okay, so life cycle of a thread. So there are different stage whenever you are creating a thread object, thread T1 equal to new thread. That means the state is new. Then when you call the start method, that doesn't mean then your thread will immediately start. You are in a runnable stage. Once you pass the 12th, that doesn't mean you are doing university, you're doing college. Okay, you are eligible, but you're not started yet. Okay, that means it's runnable stage. You are in a able to mode, you are not running. Then from runnable to running stage, thread scheduler will come into the picture. So there are JVM has a thread scheduler. So there are different ways like time slicing or priority based preemptive scheduling. So whichever thread has the highest priority, their thread will get a chance. So from runnable to running stage, thread scheduler will come into the pictures. Running means whenever you get the control in the run method. At that time, we can say it's a running. So in between, if you call a sleep or wait or yield, whatever, like Parin has explained, it will go into the block or waiting stage. We'll see those example later, but it is going to the block or waiting stage. Once a run method is completed, it will go into a terminated stage. Okay, so these are the different life cycle stages of the thread. Then thread scheduler, I already explained time slicing. By default, all the threads is priority number 5 is a normal priority. Thread priority can define between 1 and 10. So 1 is the lowest priority and 10 is the highest priority. So preemptive scheduling means whoever the highest priority, that thread will get a first chance. So we'll see here thread priority, that how can you define the priority of a thread? How can you change normal priority of a thread? And we already see this one, thread scheduler, sleeping a thread. It's what we already discussed. So no need to explain again. Start a thread twice. If you call state twice, no, you can only start one time. Second time, if you try, it will throw an exception. Okay, so calling run method, we already discussed right now that you can call the run method because it is ultimately a instance method, but it is not, but does not start a separate call stack. It does not start a separate thread. Okay, it is in the same thread, main thread. Then joining, joining a thread means, let's just try to understand, let's say if you want to make a dependency between the threads, let's say I want to read a 10 files and first thread will collect the data, which 10 files needs to be read. Then until unless first thread does not complete, I don't want to start another 2 thread. So in order to make a dependency, join basically help you out. So when you write, let's say thread.join, okay, let's say here in this example, you have 3 thread, and if you basically do, let's say, start first, and then you do th1.join. So if you call the join, that means your main thread will stop here. Your main thread will stop here. It will not go further from this stage until unless this th1 does not complete. Okay, so whatever the code you have written after this line of in the main method, that will not continue further until unless this th1 does not complete. Okay, so join means you are joining a current thread with the main thread to stop the main thread at that particular level. So main thread should not go further in order to start further code. So here, let's say after this one, if you're starting ts2.start, this will not execute until unless this completes. So you are making a dependency in short. Okay, so join is basically helping you out to stop your main thread, to wait your main thread until and unless this thread does not complete. Okay, so that's join. Naming a thread, by default, you see like the name of the thread, what thread 0, thread 1, thread 2, and it doesn't signify anything. So in a production environment, if you are having any issue in the code, and then if you're debugging your code, we discuss in the log4j framework and everything, we will see later. So in that case, what happened that thread 0, you don't know where the error is. Okay, so but if you are giving a proper name, okay, so here there are methods called set name and get name. So we already see the get name, right? Thread.get current thread.get name. But if you can change the name by setting using the set name method also. So here if they have given by using constructor also you can give a name. Okay, so you can give a thread name, but here like in constructor you can give a name. Okay, like say while you are creating a constructor, but in a thread class, okay, there is a method called t1.setName. Okay, let me show you in the code itself because they don't have example. So let's say here we have thread. Okay, so many threads we have created. So set name method. Okay, so you can basically change the thread name. Otherwise if you want to give, let's say, my thread or whatever, okay, file reader thread, file writer thread, so you can change the default name. Currently we have thread 0, thread 1, thread 2, but you can give a meaningful name if you want ultimately. Okay, so that's thread naming. Priority. So as we discussed, the priority by default all the thread has the same priority. Okay, number 5. So now let's look at this example. Let me just comment out unwanted things for now. Okay, so I have 2 threads. Okay, and I'm just putting, let's say, high priority. Putting a name with low priority. So I'm just putting a thread here, and then I'm just going to start both the thread. So what we're going to do is, let's say we're going to start first low priority thread, and then we haven't set the priority yet. Okay, so we'll set the priority also. Okay, so now I'll set the priority. Okay, and we are going to put 10 in my thread. Okay, let's put 1 as the lowest priority. Okay, we started, and then let me just go to here. I don't want to put any code for now here. Okay, it's very simple. Okay, now let's run. Okay, you see high priority, even though I started low priority thread first, right? You see here, and its answer is in front of you, right? Even though I started the low priority thread first, okay, but what you are seeing the output high first, right? This output is not constant again. Okay, let me run it again. Why? Parth, why?
Can we use click method here and try it out?
It doesn't matter.
Windows doesn't support priority.
It's not like that. Okay, so okay, let me just show you something. Okay. Okay. Let's say you're boarding the flights. Okay, you're boarding the flights. So when you're boarding the flights, there was no other passenger there, and then you were boarding. So that means you are the one. You just go through, right? But when you are there, at the same time, the passenger from the business class is there. Who will get the priority?
Business class.
Right? So if you are economy class, in the business class, so what is the statement I use? At the same time. If 2 threads are reaching the scheduler at the same time, currently what happened? Our machines are too fast. Okay, so you don't even feel that, okay, the low priority thread has started and completed, and then the high priority came. In that case, there is no priority at all, right? You understand? I mean, there is a scheduler, there is everything is working. Then why it was working first time and why it is not working second time? It is working, but priority is always there whenever two things are happening at the same time, one or multiple things. If you are the only one, then there is no priority, whether it's a 1 or 10. Okay, so this is the priority. Then the last thing is daemon thread example. Okay, so what is daemon thread? So daemon thread is a thread which is a low priority thread, and the life of the thread depends on the other thread. These two statements are very important. It's a very low priority thread, and the life of the daemon thread is depends on the other thread. So let's take an example. If there is a company who is providing selling something, some parts or some, let's say, water heater, water purifier, and there is a customer service center. Its company has no customer, then there is no meaning to have the customer service center, right? So what does it mean? The life of the customer service center is depends on the customers or main thread, right? So in Java, the thread, okay, let's just say take another example. Let's say when you are opening the Word document, you're writing something and you want to change the font as a bold or italic. So as soon as you write something, some other threads are basically changing your font, right? So behind the scene. So if your the Word document is closed, there is no significance of those threads, right? So it's kind of work, it's kind of service thread. Okay, there are worker and service thread. So let's see this example for now. I'm just creating two thread. Okay, one is worker and one is service. So I'm just running a code. Okay, you can see here. Let me just, I did not save it. Let me run it. Okay, you see, like, program is still running. Okay, you can see, even though this worker is no longer exist, but still because of this service thread, the program is still running. Okay, let me stop it. Okay, now let me just put my service thread as a daemon thread. You can do it service.set daemon true, and I'm running my code. Then you see program stops immediately. So what Java has done, that whenever there is no non-daemon thread running, whenever there is no non-daemon thread running, there is no non-daemon threads are running, then there is no need to have daemon thread. So JVM kills those thread automatically. So in this case, what happened? Let's say you set this thread as a daemon thread, okay, and then this one is a normal thread, whatever we are creating, it's non-daemon thread, okay, and then this one exists. There is no, like, this one is complete, but still this guy, the daemon thread is running. So Java sees that, okay, like, if there is no other thread running, then there is no need to have a daemon thread. Kill it. Okay, it's not only one. For every daemon thread, if there is no worker thread running, it will kill it. Okay, so now if you go back to the here, it provides the service to the user thread, background supporting task. It has no role in the life, then serve the user thread. It life depends on the user thread. It is a low priority thread. Okay, so I'll share this code. You can try it out. And next time we are going to have thread pooling topic. Okay, so everybody needs to create one example of executor framework. What is thread pooling? So here they have given one example, thread executor example. So it's multiple reading a file. Here they have given example here. Okay, so let me just show you the example here. This one is the same example we have been doing. So only this code you have to study. That's it. Only these 5 to 6 lines. Okay, you have to just copy paste and create this code. I'm sending this link. Okay, from this here, just to 1 and 2 file. Okay, what is thread pooling? So next time I will go deep dive in the thread pooling. So please try to create this example, and then we'll go deep dive. No.